Hello, everyone. My name is Doug Bay. I'm the Senior Principal Video Architect at Sinclair Digital. Sinclair Digital is a department of Sinclair Broadcasting that focuses on OTT and IP delivery. I'm excited to be here and discuss a subject that I'm very passionate about, titled Building a Dynamic Mapping Service for Video Ingesting. So what does this mean? First, let me be clear of what I mean by video ingest in this presentation. So what I'm going to focus on is really a typical VOD video ingest workflow that you may see in kind of a general video distributor pipeline. So these steps would really include origination, which would really be focused on the initial mezzanine ingest from a content provider. Then, of course, we go to transcoding, which would be encoding and decoding the mezzanine to a compressed asset that's more ready to air. We'll go to packaging, preparing the media asset for format for delivery, CDN, delivering to a CDN, and then client playback, playing back the video asset on the customer's app or web page. Within this list, there are multiple other steps, including captions, encryption, DAI, whether that's server side or client side. Most of my focus will be on a VOD workflow, though a lot of these practices could definitely be implemented into a linear workflow. Awesome. So what is a mapping service? A mapping service in this context is a service. It could be a microservice. It could be an application that is going to really make a decision on how the video workflow flows. So as an example, there's 3 categories. What services need to run for this job? What order do the services need to run in? And what commands are there for each service? And it's really important that these 3 questions are dynamic and could easily change and be scalable, because it's going to allow us to have a video workflow that will be able to change as requirements change in the future. Let's look at what services and applications may be in a typical VOD platform. If we look at ingest, we'll have the initial mezzanine delivery. We may have media package validation. In other words, we may have a service that is going to analyze all of the files in a media package to ensure that it meets our specifications and it meets the standards. In encoding and packaging, we'll have the initial decoding and the encoding of the video. We may have encryption happening at this step. There may be some sort of caption manipulation, whether that's changing the captions in the current video file or manipulating it in some way, or even maybe exporting the captions to a sidecar file. As far as packaging goes, we may package to an HLS asset or Dash. Our workflow may have some quality steps, like we may have to do a perceptual video quality on the output asset and some metadata validation on the output metadata. And ultimately, we will deliver the assets through a CDN. So this workflow is not static, and it will definitely change through different requirements that we may have. So as an example, we may have a requirement to do video quality check only for 4K video. So if SD and HD video come in, we may not need to do quality checks on them, so we will skip the quality section of the workflow. Another example would be that we may have video delivered to us from a content provider that is ready to air. So it's already transcoded and it's already packaged. At that point, we could definitely skip the packaging and encoding services that we have. But there may be a requirement that that same asset will need to have a sidecar caption file, maybe for playback. So therefore, we may be able to skip the decoding and encoding, but we still need to run the caption manipulation to be able to create a sidecar file from the caption. So with this in mind, we need to create a video ingest workflow that is dynamic and it's scalable. So here's some examples of why a workflow may not be dynamic. One of them would be that maybe all 4K assets need to be encrypted as widevine, but not for HD and SD. And so a result of that would be maybe a hard code workflow is created just for 4K assets. And again, we kind of see that over and over again. I mean, there may be a workflow that says if a caption track exists, then create a sidecar file. And a result might be that the content provider will have to send the whole media package to a whole different workflow just because it has captions in its file. And these are the things we want to avoid. We want to be able to have one workflow that dynamically changes for each one of these different requirements. So what about scalable? Again, here's some examples. Maybe a workflow is built from the ground up only to package HLS. The reason might be because there were requirements in the beginning that required only HLS, or maybe budgetary reasons of only doing HLS for now. A result might be, though, that in the future, of course, Dash may come up and may often come up. And engineers at that point will need to scramble and develop new code to get Dash working. And the output might be, again, a whole different mimicked workflow that is almost the same as the HLS workflow, but it's changed just because of the Dash packaging. Another example is that encryption may be built to only deal with widevine. And again, as a result, as new encryption requirements come up like fair play or play ready, developers must start adding new code to be able to get fair play and play ready up. And that may also result in a whole separate path just because of encryption changes. The idea here is that we want to be able to be scalable enough that as workflows change with requirements, that we won't need to scramble and hard code any new workflows into a current video ingest platform. So the solution would be to build a service-based video workflow that allows all media packages to go through the same pipeline, but determines different services that'll run dynamically. So right here we have an example of a video workflow, all the way from ingest to playout. Everything in red is going to be a different service that is run. Then yellow is going to be maybe an example of the format that'll come out of that service. So what we see here is we have the media package and then some examples of files that may be in the media package. We see there may be a thumbnail, a poster file, there may be a metadata like an ADI, there may be a caption file, there will be a video file, and there may be a segment file, for instance, a file that describes the ad times. Those files are initially, after they're initially ingested, they're going to first be read by a decision engine. The decision engine is going to be able to read metadata from each one of these files. In addition, there may be metadata that is really important to make a decision from, or not metadata, but any type of data that is not included in that media package. So the idea is that there may be business rules that the decision engine or the mapping service also reads. And from that, it will be able to make a decision from the business rules and from the media package. It can make a decision of what services need to run and how. The output of the mapping service is going to be what services need to run, what the command settings and arguments are, or any profiles that are, and what order the services need to run in. So let's give an example of how this whole thing works. So Milk Flakes, the streaming service dedicated to breakfast cereals, They often stream TV shows produced from the Breakfast Production Company. The Breakfast Production Company has agreed with Milkflakes on the following rule. If 4K assets are delivered and the asset is HLS and the show title is The History of 2% Milk, then do not transcode and create a package from the. So here's going to be an example of a flow that is going through the video pipeline that has a mapping service. So first of all, the Breakfast Production Company is going to create a rule in the customer portal. This rule is going to say something like this. If, again, it's going to say if the asset coming in is 4K and HLS, and the video, the title of the show itself is The History of 1% Milk, then skip transcoding and packaging. After they make that rule, they are going to deliver the media package. This media package will be The History of 2% Milk. The History of 2% Milk title will actually be in the metadata file, maybe the ADI. The video asset source is 4K, and it is delivered as a HLS package. So the third thing that's going to happen is the decision engine is going to first be able to read the business rules to see what rules they may have for this particular provider. It'll then check to see if it is a 4K HLS asset. Now at that point, because of the business rule that's chosen, the mapping service is going to make a map of what services need to run. So in this example, the first service that needs to run is going to be the asset validation service. So the fifth step would be that after we validate the asset for quality, we're going to go ahead and skip transcoding. And the reason why we're skipping transcoding is because the rule was that if the asset was 4K and if the title of the show was History of 1% Milk, then we will skip transcoding. But we're still going to package. And the idea there is that that rule also says that, again, if it's 4K and it's History of 1% Milk, we don't transcode, but we still want to create a dash package. So the packaging may still need to be there to create a dash package from an HLS package. So the workflow would then continue. We may do some metadata validation or video validation. There may be a JITP. At this point, the JITP may do encryption or DAI, or maybe this JITP will actually make the dash at playout. But in any case, we'll be on a CDN, we'll have a dash in HLS, and we'll play it out to the player. So some of the positive results are development time. So the content distributor didn't need to develop any new code in their workflow for any type of change. And then there's quality control. The content provider is able to have a lot of control over how their assets transcoded and the different rules of their assets. And then scalability. The content provider is able to change requirements of how they want their asset transcoded by simply changing rules. So let's look a little deeper about the media package. And more specifically, what kind of data can the mapping service get out of a media package? So let's first look at a media file itself, just the file itself. So if you look at a media file, like a mezzanine movie file, the file name itself is movie.mpeg4 as an example. At that point, the mapping service will know that the container is MPEG-4. We may also look at any other media files, like maybe an auxiliary audio file. We will see that the audio file is a container of AC3. So now, the mapping service will also have tools to be able to analyze any video assets and to extract metadata from it. So as an example, we're going to get video codec, video frame rate, resolution, aspect ratio, color space, bit rate, audio codec, and a list of video and audio tracks, including what PID they live on. We could get all this data from the source file itself, and we can make rules based on that data. As an example, a rule may be if audio track 3 is labeled as DVS and it's on PID 232, then in transcoding, output track 1 to track 2 and put track 2 on PID 200. So in order to read these files in a package, we need applications or some sort of code base to be able to read the file types. So for instance, a movie or an audio file is going to be like an MPEG transport stream, or an audio file, maybe an AC3. And there's different applications like MediaInfo or FFProbe we could use to analyze those. Most of the other metadata files, like the caption file, the segment file, and the ADI, those are going to be XML, JSONs, or CSVs, so, or even maybe just plain text. So we'll need a parser for each one of those that the mapping service will be able to utilize to read this data. So the first tool that you want to look at, I know a lot of people know this, so I'm kind of preaching to the choir, but there is MediaInfo. MediaInfo is kind of a standard for reading data from a media file itself. It's going to give you information about each track of the media file. It could also export the data as a JSON or an XML. I kind of have an example here of a command. You could basically run a command and only get, for instance, the video duration. So you could say run MediaInfo and then show me the duration of the video only. So like MediaInfo, there's FFProbe. FFProbe can also see metadata from each track of video. In addition, it could go a little deeper. It could see data from individual frames. I think both of these are excellent applications, and I would suggest you play with both to figure out what one you like the best. And again, I believe most people watching this video have probably already played with these tools and knows it very well. That's why I'm not going too deep in how to use them. So in conclusion, this has really been a high-level example of how a mapping service could really affect an ingest workflow to make it more dynamic and scalable. Again, I didn't go too deep on the technical side. Please reach out to me if you want to talk about best practices on the technical side of actually building a service like this. And other than that, I'm very happy to be able to speak on this. And please contact me for any questions or just to say hi. Thank you.